Well, welcome, everybody. It's a massive turnout given that we're competing with lunch in the last presentation of the conference, so really appreciate you being here even though you're hungry. We're very thankful to have the chance to present today as well. So what is it that we're going to be speaking about today? Tiago and I have had the great pleasure of leading a couple of teams through about 2 years worth of work to achieve some fairly audacious goals. And really the best summary of what we've worked towards is that the scenario of creating an approach to feature delivery and developing a great sense of satisfaction every day, getting as much work done as possible, delivering business value as frequently as possible. And we've chosen technology to be able to enable that approach, so a streamlined deployment pipeline, and that technology is what we're going to talk about today, taking a more traditional approach and moving and changing it into a place where we're much more empowered. So, onwards.
Well, good day. So there's not many of us. Let me get a few for who's in the audience, and perhaps we can get a more intimate session in a good way. Are you guys mostly developers? Can raise your hands if you're a developer using Heroku? Cool. Any architects? Cool. Anyone practicing DevOps in their organization? One lonely fella. We'll talk later.
Good job, Alex.
Anyone in kind of business? I won't use this too much, but any business people in there? Sweet. So we kind of know who we're talking to. We're going to introduce ourselves and we get this on the road.
Okay, so to my right is Tiago Figueiro, the VP of Engineering and Production Operations at Westfield Labs. What that means is that Tiago is a guy that is in the trenches next to his team, getting his hands dirty, and in moments thereafter, he's talking to executive stakeholders that sanction all of the roadmaps that we work on. He's a great guy to work with.
Thanks, Abhinav. So Mr. Kwasani is the CTO of Trinio. I've met him in Sydney. We did some mobile stuff together. And every company is sort of becoming a software company, or at least involved, minimally involved with technology. And knowing that we can't do everything, it's really good that we able to find a partner that can speak as if they were actually in the business, that he talks about Westfield as if he was there. His team is great. We love working with them, even though they're from New Zealand. They're all right.
Thank you.
A little bit about Westfield to help you understand some of the situations we've been and the choices that we made. We're a real estate company. We're in property development, more specifically shopping centers. By now, after a few days, you've seen the Westfield Center on Market Street. We've got 87 of these across the world, and the problems that we solve, we have to consider that scale. So to give you an idea of the numbers, there are over 20,000 retailers. They do roughly $40 billion a year. We see over 1 billion people coming through our doors every year. Next year, we open the World Trade Center in New York. That one alone, I think we're expecting around 400,000 people a day. So even though we're a traditional company, we're in an industry where we have to innovate to stay relevant. Frank Lowy, our co-founder and chairman, very interesting guy. He's still working, he's almost 90. He said that evolution and change are the words for shopping center success. And we did that. Our centers have been transformed from this place where you go to buy stuff to a destination where, you can also buy stuff if you're there. You can see in San Francisco, but all the centers that we don't only have a food court, you're going to have a dining option, you're going to have world-class chefs there. We do lots of events. Today in Westfield London, and actually today started a couple hours ago, they're doing this auction for old movie props and costumes. There's heaps of stuff from James Bond, and I like James Bond, so I wish I could have been there. So in keeping this culture of innovation, Westfield Labs got created. The mission is sort of simple, but executing is more complicated. We aim to enhance the shopper, the visitor even experience by applying technology, not only while they're there, but before in the planning, when they're arriving, when they left, after they've left. And the Westfield API sort of enables us to do that because we can shortcut a lot of the ideas that we have. We don't have to start from scratch. It's sort of like building blocks for us.
So another way of saying this is that we present them all with an API. And that's a fairly large concern as a whole, in that the domain is huge, and so we've carved it up into discrete concerns, which means that we've got microservices that all come together in a concerted effort in a service-oriented architecture, and they begin their life in the confines of a private firewall network. And we are now going to talk to you about those and how we've moved them out and away onto Heroku.
So these are some of the applications that collectively we call the Westfield API. There are more than those. Today we're going to focus on 3 cases. 2 of the cases, one is going to be the category service. The other one is going to be the event service. So being a traditional company, this stack has been in a collocated environment. Nothing too exciting there. But I want to talk about some of the pain and inefficiency and some of the stuff that we just weren't happy about. So you see GitHub Enterprise instead of github.com. I just didn't want to have the conversation with the lawyers about data sovereignty and security and all that, so we'll buy the stuff, we'll host it. It's all good. With Red Hat, we use RPMs to deploy the stuff, so now you got to manage the spec files. It's something that you really didn't have to do, but we did because of the infrastructure. Satellite has an API, but it's kind of soapy and flaky at times. Sometimes you deploy, it doesn't go, you try again. And all this stuff being in a data center, in a private network that we control, means that if we want to showcase that to a stakeholder, they also need to be on that network. If they're not in a Westfield office, they need a VPN account, and now you got to manage VPN account, and so we know how fun that is. So a bit of inefficiency, a bit of happiness, that's what made us want to improve.
So to state the obvious, we want efficiency and happiness. And the way in which we want to achieve this is, again, and making the point again, it's through feature delivery. So rapid iterations of work that we're empowered to be able to get them through to production as fast as we can. And the supporting technologies that we have should not hamper our efforts. We should be focused on the form and function that we are sponsored to deliver.
So that was the first one. So I told you 20,000 retailers across the world. We got to classify them and categorize. So we've got a global taxonomy. First tier or first category is what the retailer is. Is it fashion? Is it food? And then on the second level, is it kids fashion, women's fashion? Is it a bar? Is it a restaurant? The reason we picked it as the first one is, first is we needed it. We needed it for an actual product. It wasn't we didn't make up an excuse to play with Heroku. We needed it live. It was also a new service. It didn't exist, so we could come in with a fresh mind, get it going straight into Heroku. We didn't have to worry about migrating anything. And last but not least, as we found out later, was we could get away with deploying a read-only service. What I mean by that is, imagine the stores in our malls. These retailers don't come in and out all the time. Their leases go for years, some of them for a decade. So it's very rarely that we have to introduce new categories or new stores. And when we do that, it was acceptable that we would just release the application again. So that happens, I don't know, once or twice a month, and that's okay.
So let's have a little closer look. I'm going to start with a disclaimer, because this is not going to be the sexiest piece of technology you will see. Here we go.
Well, good thing it's on an iPhone. There's your pen.
There we are. All right. So the point is that this thing needs to get up and running and present a read-only interface. So this is a Ruby application. It's using the grape gem to represent the categories as a resource. So this is the rackup file, and the line the cursor is on, line 26, is saying that I'm going to load a whole bunch of categories. So we read files in the file system, and we build up categories that we stash in memory. So what we've got is the instantiation of 2 countries. The majority of Westfield centers are in the US and Australia. So we instantiate 2 countries, and then we just add lots of centers to those country instances. And then we do something magical, which is we load categories from a CSV. So as As I've said before, CSV over FTP still makes this world go around. This is what we do. Now, the motivation around a CSV, and I told you this is not crazy tech, the motivation around this is that this is a hierarchic, tiered structure of categorization that a non-technical person can manipulate. They can jump on to github.com, which we moved away from the enterprise stack that we were running, and they can actually manipulate these category structures and commit in situ, and then I'll show you later how we push through to production. So what that CSV structure turns into is this. So JSON. Now, this is something that we can programmatically transact with. So that CSV structure turns into this. It's held in memory. It's read-only. It's very fast. It's queryable. So this is a scoped query to ask for the categories that are relevant just to the San Francisco Center. So if you look at the URL, you can see that I'm calling out for the San Francisco Center. And then because I'm always thinking about food, and I'm sorry to mention it at lunchtime, this is a scoped query for the food drink category for the San Francisco Center. So this is a simple thing operating on Heroku right now, and I'd like to show you how it actually is used. This is the San Francisco Center site, which is just around the corner. So I click on stores, and here are my tier 1 categories. I choose food and drink. I get to choose cafes because I also like coffee, and I'm going to show you that Café Central, in my opinion, is the best coffee in the house. So I've traversed tier 1 category, tier 2 category, chosen a store, and a non-technical person has been able to manipulate a bunch of CSV files, and we can get that up in no time. And I'm going to later elaborate on what we actually have learned by doing this in this particular way.
And then we move to the next service, adding a bit more complexity. I'll describe what an event is for Westfield. It's something that happens in the mall, in a location assigned the mall. It's got a date and time associated with it, and it spans. It could span a date and time. So we're close to Christmas. You're going to have an event. Santa will be in the San Francisco Mall food court from the 10th of December to 24th. I don't know, from 10 a.m. to 3 p.m. or until he's fed up with the kids. The reason it makes it a little bit more difficult is, one, that service already existed, so it was in a collocated environment, and we were going to have to migrate it to Heroku. The second point is that we couldn't get away with that deal with the read-only service. Events change a lot, so every day, people in the malls, people in head office, they're entering new events, they're changing them, sometimes they delete them. And we had to figure out a way of allowing that in Heroku and still make sure people weren't entering just any one internet. So Abhinav is going to describe the difficulty in achieving that.
So the main difference here is that we go from a read-only resource to one that you can mutate. Now, consider a huge fleet of microservices running inside of a nice, comfortable, secure, firewalled private network. You can establish trust just based upon their proximity to each other and their location relative to each other. What if you take the event service, pull it out of the comfort zone of the private network, and drop it onto Heroku, which is being on the public internet? How do you protect the events? How do you protect them from change, either inadvertent, unintentional, malicious change? So authentication and authorization around the resource is the next major hurdle. Identity, it's a big deal. There are a couple of scenarios to work through. So as a center manager of the San Francisco Center, I wish to log into what we call the back office console, and I want to add a new event to my center. Now, this is a web application that marshals and wrangles all of the microservices and makes meaning of them and shows them to people, as you can see. So that scenario is a human interacting with the event service, so person to program or software interaction. And so that's an authentication scenario. Now, the other thing that takes place in the chain of events is that the back office console has middleware that wants to eventually transact on your behalf. It's going to interact with the event service and add a new event. So that's a machine-to-machine integration. Now, one design principle to bear in mind here is that we wish to use protocols that are accepted by the industry. They're mature, they're easy to work with, and we don't want to come up with some crazy proprietary tech that no one will ever understand, because we would like to add third-party services and third-party consoles to our fleet. So this is, I'm going to tell you in 45 seconds what took many months to do. The top right corner, the green stuff, is SAML authentication. So SAML allows us to be able to identify the person. So I log into the application console. I'm redirected to a user console, which we have built. So the user console is basically a login screen. I'm challenged for my username and password. I put that in. And then I'm redirected, and I transact with the user service. So the user service is basically a broker. And it is broking a transaction with an identity provider. Now, it's in place because we want to have the choice to use any identity provider that we choose to. Today, we use Okta. Tomorrow, we may choose to use a different one. Now, and that buys us flexibility and choice. So eventually, the identity provider passes or posts the SAML assertion back to the application console. So the console is now aware that I am who I say I am, and then it transacts on my behalf and wants to talk to the event service. So this is where OAuth 2 comes into play. This is the machine-to-machine integration and authentication piece. So what we have is a doorkeeper. In fact, we use the doorkeeper gem in the access service, and it hands out OAuth 2 tokens. And these tokens are bound to me as the person, as well as the service. So the console is identifiable, the person is identifiable by the token. I attach it, I send it to the event service in a request. The event service takes the token, validates it against the access service, and then it can do what it needs to and pass back a response. So the salient points about this are that we can genericize and now add any number of consoles and services that we choose to. And that is a massive win for us. The other thing is that they can run in any network that we wish to put them into. Because if they're using a secure transport protocol like SSL, we all know how secure SSL is, everybody.
You guys have been reading the news.
And if you haven't, then talk to me afterwards, please. Then we can actually locate these consoles and services wherever we like. The other thing to consider is that the console, the user console, and the two access services buy us the flexibility to be able to use an identity provider of choice, and we can pivot and change and make different choices as we go forward. So this is how we've moved forward from the trivial case of a read-only interface that's sitting, an API that's sitting out in Heroku. Now we can transact with trust. So how do we actually pick up a service and move it outside? So we've used some tools to do this, and routing is the first one.
The idea of the routing layer came up with you saw the number of services. We got about 25, going 30. Just to keep sanity, the routing layer allows us to make requests, and the routing layer decides which backend that goes to. So we don't have to memorize different endpoints or keep a note of them. It's all centralized in that place. That was the first reason we put it in, but then it became a convenient point for other stuff. The category service was a fresh one, but the event service we had to migrate. And then the routing layer helped with that, because if the requests are all going through the routing layer, and you have the two services, you can say, hey, routing layer, stop sending to the collocated environment, send that to Heroku, and we managed to migrate with the minimum downtime. The other things that the routing layer became convenient for were, at least in the beginning, we thought about using for access control, and we tried it with Mastery v2 at the time. It didn't work quite well. Our scenario is a bit more complex that we had to roll it back and rethink, and this is when the SAML and OAuth thing came up. But if you just have a simple decision to make, do I need an API key or not, that might solve the problem for you. The other point that the routing layer helps is about caching. So I'll extend that a little bit, but not too much, because most of you guys are devs, and if anyone has questions, just come to me later. So caching is that choice between performance and content freshness. Do I want it fresh or do I want it fast? When you think that you're removing something that's sitting in a data center in a network where you have sub-millisecond latency, and you're going to move that to the internet, you're going to introduce an order or more of magnitude of worth of latency. So for us, in the worst case, from Sydney to US East, there's about 200 milliseconds. You do that enough, you're going to start frustrating people. So introducing caching, think about that. Think about the geolocation of your caching nodes. The other thing about caching is that it kind of complicates the whole deal, right? So we managed to simplify it a bit by not caching every single API. We cache the end result. So when Abhinav showed you the Westfield San Francisco landing page, that HTML is what gets cached, not just each individual request. So that makes it simpler. And then if you find yourself having to cache some of these individual endpoints, remember that a little bit of caching could take you a long way. If you have a busy service, something that's doing hundreds, thousands of requests per second, and you cache that for 30 seconds, you could be taking yourself out of some trouble just by doing that. And last but not least, the point about Heroku, right? If you've got a problem with a resource, and you can solve that by going to Heroku and sliding that thing to the right, you just threw some money at the problem. You don't have to worry about caching, not yet, and the dashboard.
And so the last of the three tools that we're going to talk about is the dashboard. Everybody needs a dashboard. We have one, and you can actually have it too. We're happy to actually share the dashboard code with you. We need to genericize it. We can open source it, and we can share it with you.
Take the embarrassing code off.
Take the passwords out of the code, all that stuff that you never do, right? So this is the dashboard. It represents 3 environments: integration, UAT, and production. And it shows you the flow of change through these environments. And there's a few things to notice here. We can see the code that's running using the Git icon within each environment. You can see what Nagios is telling you about operational monitoring of that particular service in an environment. Jenkins is showing us whether or not tests are passing, so that's CI happening at each environment. And we've got New Relic for transaction monitoring, exception surfacing, and performance monitoring as well. So let's just think back to that dinky little category service that we released, the first thing that sat on Heroku as opposed to within the firewall. How do you put that into this when everything you interrogate lives inside of a firewall? Now you have to talk to a service that's running New Relic externally. Now you have to know what code it's running out there. You have to run builds on a service that's no longer within your private network. All of these things have taught us a lot about how to actually make a service live and what are all the supporting components that it takes to have your microservices living in a diversity of locations. So yes, it was a trivial thing to do, but this is what we learned. Now, a couple of things here. That notes icon is used for release notes, and I'm going to show you that in a second. And that pirate ship down the bottom is a link you click once you've logged in, and then you have one-click release to production from UAT, which is very powerful.
And it's no coincidence that the category service is the one that's all green. That's the one that's running on Heroku. So
it moves quickly. There's a lot of rapid change that we can put through it because it's just git push as opposed to RPM deploy. So that pirate ship button gets you to this point. So these release notes are comprised of commit messages and pull request messages, which our developers will issue during feature delivery. And this is completely within the flow of what they do every day. They don't need to go outside of their workflow. They just do what they do. And the dashboard is a dashboard, but it's also an application in its own right that enables us to move quickly and then communicate the change to stakeholders rapidly, do the deploy rapidly, and then realize you made a mistake, and then fix your mistake rapidly just as quickly. So this is one of the main things that the dashboard helps us with. Again, happy to share it with you. So we've talked about this notion of a read-only service. We learned a lot about infrastructural componentry, bringing it into our fleet. And then we talked about identity management, which is a major concern. How do you trust a service that doesn't live in your network anymore? And then we have the demon of scale. So 1 billion visits every year. And of those visits, some people will choose to be anonymous, completely anonymous, and some people will be happy to identify themselves to Westfield, and then we can become aware of who you are and achieve what Tiago was saying earlier, which is We want to give you that enhanced experience even before you get to the mall. So you know that awful experience of driving a vehicle into a parking garage and finding a place to park and then taking a little ticket and paying for it and so on. Well, you can now nominate your favorite car spot and try and grab it before you get to the parking garage, or car park, if you will, for the Antipodeans in the audience. You can pay for it using your Westfield app. It's a seamless experience. You can order your food using food.westfield.com and have it and pay for it and have it ready for you when you go and pick it up within the mall. You can subscribe to a particular event because Tiago loves Justin Bieber and he wants to go to every Justin Bieber concert.
Bond girls, man, the joke was
Bond girls.
Justin Bieber.
I had to go, Justin. So you can subscribe to an event. And you're actually interacting as a person with that suite of microservices that we have. So the metadata service is actually a consumer of a time series of data points that describe an identified visitor's interaction with the mall that has an API. So 1 billion visits a year. Let's say we have 100 billion data points every year. Just make that number up from 1 billion. And I would say that's fairly large data. Maybe we could even call it big data. Come on, people. So
come on, guys.
So the metadata service, the event horizon we have basically is this notion of being able to support a few specific concerns. Now, we can suffocate ourselves with the fear of what sort of performance do we need to be able to support for fairly large data, and make a specific tech choice. We've chosen what we know really well. We know Ruby really well. We know Postgres really well. And we've got a very high-performance user metadata service that's running on Heroku right now. And in a year's time, we can change our minds. We can choose another technology when our choice today becomes non-performant. And the great thing about that is I don't have to call my ops brethren and say, hey, can you learn about how to build a high-performance set of infrastructure to host this new thing I want to build. I can use Heroku build packs, and I can get something built up, and I can make a choice to use some different tech. And that's the final salient point here, which is that in terms of getting something done, we have it done. It's done. It's simple. It works. The next step will be to improve its performance. I can guarantee that. And we're comfortable and not intimidated by making that change in the near future if we need to.
All right, we made it. So if you guys are hungry, if you haven't had your sandwich yet, after a few days you must be sick of sandwiches. The food thing that he mentioned is on food.westfield.com. You can order now, walk there, pick it up. Shameless plug ended. You can take some notes and justify your travel badges. So first thing we learned there was about picking something small. Don't worry about how small. We did was almost like could have been a read-only JSON file in production. So the value was in the journey, learning how to make that thing live. Think about your incremental steps of complexity. So we thought we were just adding, a couple little difficulties with the event service. We figured, we're going to migrate this thing, and then we're going to figure out how to do access control. Access control took months, so it was a good thing that we didn't pick anything bigger or harder, because we would have been in trouble. I mentioned the routing layer. It was really useful for us. It might become useful for you in the scenarios that I mentioned. So the access control, keeping your sanity with a number of different services in the back end.
We use Akamai currently.
We are using Akamai, yeah. We tried Mashry and for caching as well, and it was caching some weird stuff on version 2. We haven't tried version 3 yet, so we kind of fell back to Akamai. But Akamai also is slowing us down on the releases. Akamai takes 40 minutes in staging, over an hour in production. So if we wanted to releasing multiple times a day and you're stuck waiting for Akamai, you're kind of not good. So we look into that. So the routing layer is a good thing for you. And last, the dashboard. If you're releasing all the time, you want to share the love and broadcast that to your stakeholders. And for us, it helped us identify everything that you need to do to get something live, but also helped build trust with all the stakeholders in the company. And this is it.
Yep.
We're going to take some questions if there are any.
please.
Did you use any framework on top of Ruby or API, like Grape or like that?
Yeah, so the category service is using Grape. Yeah, and with Swagger for documentation. So all of our services have Swagger docs so that we can programmatically generate documentation and maintain in situ within the definitions around each action or endpoint for the APIs.
And we open source something called the API canon that helps with that as well. So if you look it up on the github.com/Westfield Labs, it'll be there.
Hello?
Could you talk a little bit about how your teams, your internal teams at Westfield and so on reacted to this change? Was that difficult for them to adapt to this new approach, or how did that work? And how do your team, Trinio and Westfield work together and make all that happen?
It's a good point. With that dichotomy with dev and ops, right? The ops guy holds all the keys, and the engineer needs to talk to the ops guy whenever they need something. We've been on this journey of empowering the developers, having them own the full stack, so from the code they're writing on the machine all the way to the production. If they feel good about releasing something, they release it. We used to have all these rules about don't release on a Friday, don't release after 4 p.m., and we're much less prescriptive these days. We go, you know what, mate, you own it. If you want to release it on a Friday, good for you. But if you break it, just be ready to stay here and, I don't know, order you some pizza, but you're going to fix it. And this is really welcome. The engineers like it. And coming in, Trini, do you want to give your point of view? Because you saw the old...
Yeah, so when we started working together with Westfield in early 2012, we had to get a VPN account to get in. You needed to have Active Directory accounts, and then there's a third account in order to be able to use Jira, which we use for our issue tracking. And then access to Jenkins required another account, and it was just this. There was so much friction involved in actually doing our work. And in our conventional stack, we'll use Heroku, github.com, and we choose Pivotal Tracker as a good place for issue tracking. And so we were stifled, really. And the cool thing about working with these guys is that they listen. And we were...
Most of the time?
Most of the time they listen. What is it now? So the notion of allowing us to be autonomous and actually improve things, they've been very good in letting us do that. So we're really proud to have the chance to have worked on most of this stuff. So a lot of this stuff is based on a collaboration between a couple of Westfield devs and a few Trinio devs. It's a pretty proud thing for us. Any more? Any more?
All right. Maybe come buy us a beer then. We'll answer more questions.
Thank you very much.
I'll give you the code for the dashboard. Thank you.